Hello everyone, this is the second video about Windows internals. Today I will explain the new mechanism, the asynchronous procedure call, the interrupt request level and thread DPC. Okay, I will analyze everything and we will see what is the function of each mechanism. Okay, so what we will see on this PowerPoint, we will see the definitions of APC, of IRQL and Thread DPC. We will see the functionalities, we will see examples, we will see the connection with DPC and ISR, we will describe the whole procedure, we will see how we can troubleshoot these three things. Okay, and I will give you some more sources to do further reading. Okay, so let's see the definition of APC. Okay, asynchronous procedure call, or APC, is a technique in Windows that allows concurrent execution of small code portions without interrupting the main execution. It is used to handle fast tasks such as user interface updates and error management while maintaining system stability. So what that's saying, when we have a main execution, a task that is executed from DPC, because we're using asynchronous procedure call, this mechanism is using only with DPC, with deferred procedure call, not with ISR. Okay, so when DPC will execute a task, the biggest part of this task will be executing from DPC, and a small part of this task will be executed from APC. Okay, that's the mechanism of APC. Okay, is helping DPC. Okay, that's the main concept of APC. Let's see the functionality of APC. Asynchronous procedure call allows tasks to operate independently, improving system efficiency by enabling code to be executed asynchronously in response to specific events or requests. Also, I must say that when APC is executing at the same time with DPC, everything are normal. APC doesn't interrupt the procedure of DPC. Okay, it's very important to understand that. So let's see this diagram. We have the application, he's sending the request named APC request. Kernel will convert to this request as APC. Okay, and this part of task will execute as APC routine. Okay, will be completed, and after that it will came back to application. Okay, that's the functionality of APC. So let's see an example of APC. An example of using asynchronous procedure call is when an application is loading graphics from a file. Instead of waiting in a blocked state, it can utilize an APC to display the loading progress of the graphics in a pop-up window. This way, the user can continue working and monitoring the progress concomitantly. Okay, so that saying here is when something is loading, a task that DPC will execute, at the same time can utilize something to display in the user, the APC. Okay, and on that case, displaying the loading progress of the graphics. Okay, in a pop-up window. So let's see also the diagram. Okay, we have the application. He's sending the request that must be executed from APC. Request load graphics. The kernel convert to APC, so the execution will be done from APC. The display progress will be completed, and will continue working and monitoring the progress. That is a simple example of APC. Okay, let's see the definition now of IRQL, second mechanism that we will discuss today. The interrupt request level, or IRQL, is a priority level in Windows that determines the importance of tasks. It assigns lower levels to more critical tasks, allowing efficient task management. Lower IRQL values enable more tasks to run, while higher IRQL's value offer protection and prevent errors. So, a task has the IRQL. IRQL defines the priority of this task. Okay, and from that, DPC and ISR will see with which way will execute with what way will execute the tasks. Okay, this defines the the priorities. Also, the priority of IRQL is defined from the algorithm that is running from behind, from the task. Okay, it's depends from the developers. Okay, it's not from different from Microsoft. Okay, it's from developer. Let's see the functionality of IRQL. Interrupt request level prioritizes tasks for smooth multitasking. So let's see a big diagram to understand what we said. We have an application is sending a request. Kernel will make the IRQL change, and the IRQL will execute. So this is the IRQL giving has the critical task. Is a critical task has the highest priority. So this critical task will be executed from ISR. Okay, will be completed, and IRQL will be restored to the default IRQL, to the default priority, to the lower priority. The default priority of IRQL is the lower. Okay, and the application will continue. Okay, that's the functionality of IRQL. So let's see an example of IRQL. Imagine your computer performing multiple tasks at the same time. We listen music, we play Spotify, and at the same time we're browsing in internet. For example, we're using Instagram, we're scrolling in Instagram. Okay, so the IRQL will decide from the algorithm that is running from behind. The IRQL will decide the priority of these two tasks. Okay, will give the high priority for the music. You have no interruptions during when you listen music, and will give low priority, low IRQL for tracking mouse movement for your browsing. Okay, that's the main concept of this example. Okay, so let's see also the diagram. Okay, we have the application here is sending the first task, play music. The kernel will help to execute the high IRQL. Okay, the first execution is to play music as high IRQL in priority, as high IRQL priority, in order to execute smooth music playback. After this task complete, we have the second task, task 2 track mouse, will execute as low IRQL, and the second task is completed. And the same procedure will continue. Okay, the next tasks with the same way. IRQL will decide which priority gonna have its task. Okay, and that was the example of IRQL. Last mechanism is Thread DPC. So let's see the definition. Thread DPC coordinates tasks within a system, contributing to overall stability by prioritizing and executing tasks efficiently. It helps minimize interruption and disruptions, ensuring a smoother and more responsive user experience. This mechanism allows the operating system to allocate processing time effectively to various tasks, maintaining optimal performance. So, first of all, Thread DPC is a navigator for Deferred Procedure Call for DPC. Okay, and as you understand, Thread DPC prioritizing and executing tasks. Okay, so Thread DPC helping DPC to prioritize and execute tasks efficiently. Okay, and this helping to minimize interruptions, have a smoother and more responsive experience. Okay, that's the role of this mechanism in the operating system, in this procedure of tasks, of interrupts. Okay, let's see the functionality of Thread DPC. Thread DPC enhances system stability through task organization. Okay, he organizes the tasks. It coordinates tasks, prioritizing critical ones for smooth execution by optimizing task sequences. Thread DPC reduces disruptions, ensuring a responsive system experience. With that way, as you can see, on the example of music playback and mouse scrolling, Thread DPC choose to prioritize the music and give a delay for mouse movement. Okay, that's the concept. Okay, of Thread DPC. Let's see a diagram to understand better what we said. Okay, we have the application task load graphics. Okay, the kernel will execute in display progress APC. Okay, and well, this task complete, the Thread DPC will organize the next tasks, okay, for the stable operation, okay. So it's an organizer Thread DPC, okay. Let's see an example of Thread DPC. This example has the name smooth image refresh. Main thread handles user interactions and other tasks. We have the description on the left, and on the right we have the diagram. So on the second description we have image refresh. The application updates the screen with a new image. Okay, so first is the main thread user interaction and other tasks. The next is the image. So here we're seeing how Thread DPC is prioritizing all these things. Okay, prioritize first main thread user interaction and other tasks. After that, prioritize the image refresh update screen with new image. After that, Thread DPC create a specialized low priority thread for the refresh. Next, image refresh Thread DPC takes care for image update, and the last priority is to smooth response after refresh is done. Main thread updates screen and continues user response. Okay, so that's how Thread DPC prioritizes this procedure. Okay. Now let's see the connection with of APC, IRQL, and Thread DPC with DPC and ISR. Okay. Before I show you everything, I must say that ISR is connected with IRQL, obviously, and Thread DPC and APC, Asynchronous Procedure Call, is connected only with DPC. These two mechanisms is only for DPC, not for ISR. Okay. I will help you to understand on the next slides. Okay. So the DPC and ISR mechanisms are essential for handling interrupts and tasks after they occur. In close collaboration with DPC and ISR, the APC, IRQL, and Thread DPC mechanisms play a role in the organized operation of the system. Okay. The APCs are programmed by application to exchange information, while RQLs and ISRs regulate the priority of interrupts. Thread DPCs organize tasks after interrupts, ensuring stable operation. Okay. So every mechanism has a specific role, okay, and all these things cooperate together, okay. It's really beautiful, guys, to understand that. And I have a very simple diagram. The first is the ISR, because when we have an interrupt, the first responder is ISR. After that, the IRQL will define the priority, and if the task is deferred, DPC will execute, and a part of this task will execute from APC without interrupt the DPC execution, and also Thread DPC will navigate DPC. Okay. Let's see the summary of mechanisms that we saw today. What is APC? APC refers to the ability of an application to initiate a task that runs concurrently without waiting for it to finish. This aids in efficient task management and smooth communication with the system. What is IRQL? IRQL determines the priority level of interrupts in the system, ensuring seamless multitasking and efficient resource allocation. And last, what is Thread DPC? Thread DPC organizes tasks that need to be performed after interrupts, ensuring smooth operation and minimizing disruptions in the system. Let's describe the whole procedure, and on this slide you will see all mechanisms connected from the previous PowerPoint and this PowerPoint. Here we have the description, and here we have, on the right side, we have the diagram. Okay, so we have hardware interrupt. The ISR handles the interrupt and is called to execute the corresponding task. Okay. If it is a critical task, we'll execute immediately. Otherwise, we'll upgrade the priority. Okay, and the DPC will execute the delay task with a new higher IRQL. Okay, after that, APC will execute a part of task, a part of the algorithm. Okay, continue execution of tasks code, and the DPC will continue. The DPC navigates the DPC in executing specific parts of the task's code. Okay, so that's the whole procedure if we combine all these mechanisms together. Okay, because all these mechanisms work together. Okay, As you see, you have a full picture now about what is happening when we have a hardware interrupt, okay, and that is beautiful, I think, guys. Okay, I think it's really simple now to understand. I think you understand very well what are these, what are all these mechanisms. Okay, now let's continue to troubleshooting. Troubleshoot all these mechanisms is Windows Performance Analyzer only, not Latency Monitor. The Windows Performance Analyzer, as we said also on the previous PowerPoint, is a powerful performance analysis tool for Windows systems designed to aid in understanding and identifying issues related to the APC. Anyways, just this tool can help you to troubleshoot, to analyze, to detect issues on the system, to detect if if it's something going wrong and it's caused from APC or IRQL. And also I must say that IRQL is basically the same with when you using MSI mod utility, you're changing the RQL, okay, of the drivers of the tasks. So you define the RQL to be on a specific priority. For example, you're setting the driver of your graphics card high priority or the audio to low priority, okay. So you must be very careful, okay. And before we close, as we said, we will see the further reading. Again, I will recommend you Windows Internals Part 1 and Part 2 books. Okay, here we have the authors, and also here we have the documents of APC IRQL and Thread DPC, the official documents from Microsoft, okay, to read them, okay. Also, we'll have everything in the description, so don't worry. And that's the end, guys. I hope you enjoyed this video. It was bigger than the previous PowerPoint. I like this series. I like this concept of videos that I explain any mechanism of Windows, what is happening behind the scenes, and I hope you enjoy that also. Anyways, see you on the next video. Okay, very soon you will see the next video of Windows Internal 3. Okay, I will analyze the memory management, what is happening to the memory of Windows. Okay, and I think it will be very interesting. Okay, anyway, guys, thanks for watching. Thank you for your support. I love you, everyone, and see you soon.